Our first given equation is from page 106, which is number 9. D squared plus 4d plus 4 times y is equal to x e to negative x. First, let's find yc by solving d squared plus 4d plus 4y is equal to 0. And the factors are d plus 2, d plus 2, where d1 is equal to negative 2 and d2 is equal to negative 2. So yc is equal to c1 e to the negative 2x plus c2x e to the negative 2x. To determine the particular solution, we need to use the method of undetermined coefficient. So, in this equation, yp is equal to a1 e negative x plus a2 x e to the negative x. So, solving for unknown, which is a sub 1 and a sub 2, let's integrate yp. So y prime to a1 x plus a2. The second derivative is a1 e negative x plus a2 negative 2e to negative x plus x e to the negative x. So, substitute these derivatives to the differential equation. So, the derivatives are substituted to the differential equation. So, by simplifying, we will get this equation. So, in order to get the values of the constants a sub 1 and a sub 2, we will equate the coefficient e to negative x to the both sides of the equation. So, that will be a1 plus 2a2 equals to 0. And equate coefficient x e to the negative x. So, a2 is equal to 1. So, we can now get a1, which is negative 2. Substitute it to the yp. So, yp is equal to negative 2e to the power of x plus x e to the power of x. So, the general equation solution is y equals to c1 e negative 2x plus c2 e negative 2x minus 2e to negative x plus x e negative x. So, this is the final answer of the given equation. Our second given equation is number 13 in the page 106. So, y double prime plus 5y prime plus 6y is equal to cos x. So, by finding yc, we need to solve y double prime plus 5y prime plus 6y equals to 0. So, factoring it out, d plus 2 times d plus 3, where d sub 1 is equal to negative 2 and d sub 2 is equal to negative 3. Thus, yc is c1 e to negative 3x plus c2 e to negative 3x. So, by finding yp, or the particular solution, we need to use the method of undetermined coefficient. So, since cos x is e to negative x over 2 plus e to the x over 2, thus, y double prime plus 5y prime plus 6y is equal to e to the negative x over 2 plus e to the x over 2. We need to separate e to negative x over 2 plus e to the x over 2 in order to easily get the particular solution. So, first is the e to the negative x over 2. Thus, yp1 sub 1 is equal to a1 e to the negative x. And the second yp sub 2 is from the e to the x over 2, which is a2 e to the x. Thus, yp is equal to a1 e to negative x plus a2 e to the x. To get the unknown, derive the yp. So the first derivative of yp is negative a1 e to negative x plus a2 e to the x. And the second derivative is a1 e to negative x plus a2 e to the x. Then substitute it to the differential equation. So the first derivative and the second derivative of yp is substituted to the differential equation, which is y double prime plus 5y prime plus 6y is equal to cos x. So this is the substituted equation. So simplifying the substituted equation, 2a1 e to negative x plus 12a2 e to the x equals to e to the negative x over 2 plus e to the x over 2. In order to get the unknown, which is a1 and a2, we need to equate the coefficient e to negative x to the both sides of the equation. Thus, we will get a1 is equal to 1/4. Then we need to equate e to the x to the both sides of the equation, and we will get a2 is equal to 1 over 24. Then yp is equal to e to negative x over 4 plus e to the x over 24. Thus, the general solution, which is y is equal to yc plus yp, y is equal to c1 e negative 3x plus c2 e to negative 2x plus e to negative x over 4 plus e to the x over 24 is the final answer of the given equation. Our third given equation is number 30 on page 107. D cubed minus 7d plus 6 times y is equal to e to x minus 5e to 2x. In order to get the complementary solution, which is yc, we need to solve d cubed minus 7d plus 6 times y is equal to 0. So, factoring it out, d minus 2 times d minus 1 times d plus 3, where d1 is equal to 2, d2 is equal to 1, and d3 is equal to negative 3. Thus, yc is equal to c1 e to negative 3x plus c2 e to the x plus c3 e to the 2x. To determine yp, the undetermined coefficient method. Thus, we need to separate ex minus 5e to e2x in order to get the yp. So, d cubed minus 7d plus 6 times y is equal to ex, where yp sub 1 is equal to a1 x e to the x, and d cubed minus 7d plus 6 times y equals to negative 5x, where yp sub 2 is equal to a2x
Summing
e to the
up
2x. Yp sub 1 and yp sub 2, yp is equal to a1x e to the x plus a2x e to the 2x. Thus, deriving the yp in order to get the value of the unknown, the first derivative is a1 e to the x plus a1x e to the x plus a2 e to the 2x plus a2 2x e to the 2x. And the third derivative is a1 times 3 e to the x plus x e to the x plus a2 times 12 e to the 2x plus 8x e to the 2x. Then we need to substitute it to the differential equation. So this is the substituted differential equation of the third derivative and the second derivative of y. So simplifying the substituted differential equation, it is negative 4a1 e to the x plus 5a2 e to the 2x equals to e to the x minus 5e to the 2x. Equate the coefficient e to the x to the both sides in order to get the unknown a sub 1. Thus, a sub 1 is equal to 1/4. And equate e to the 2x to get the unknown a sub 2. Thus, a2 is equal to negative 1. And yp is equal to negative x e to the 2x minus 1 over 4x e to the x. Thus, the general solution is C1 e to the negative 3x plus C2 e to the x plus C3 e to the 2x minus x e to the 2x minus x e to the x over 4. That is the final answer of the equation. Our last given equation is number 70 of page 108. In order to get the complementary solution, we need to solve y to the 3 prime plus 3y double prime plus 7y prime plus 5y is equal to 0. So d cubed plus 3d squared plus 7d plus 5 times y is equal to 0. And factoring it out, d plus 1 times d squared plus 2d plus 5 is equal to 0. Thus, d sub 1 is equal to negative 1, d sub 2 is equal to negative 1 plus 2i, d sub 3 is equal to negative 1 minus 2i. Applying Euler's identity, thus, yc, which is c1 e to negative x plus c2 e to the 1 minus 2ix plus c3 e to the 1 plus 2ix will be c1 e negative x plus c2 times cosine 2x e to negative x plus I sine 2x e to negative x plus c3 times cosine 2x e to negative x plus minus I sine 2x e to negative x. So, the particular solution is x times a1 cosine 2x over e to the x plus a2 sine 2x over e to the x, where a1 cosine 2x over e to the x plus a2 sine 2x over e to the x was multiplied by x to account for cosine 2x over x in the complementary solution. So deriving yp in order to get the values of the unknown, which is a1 and a2, so the first derivative is a1 cosine 2x e to the negative x minus a1x cosine 2x e to negative x minus a1 2x sine 2x e to negative x plus a2 2x cosine 2x e to negative x plus a2 sine 2x e to negative x minus a2x sine 2x e to negative x, and the second derivative and the third derivative of yp. So the first, second, and third derivative of the yp is substituted at the differential equation, thus simplifying it, it will get negative 8 a1 cosine 2x e to negative x minus 8 a2 sine 2x e to negative x equals to 16 e to negative x cosine 2x. Equating the coefficient e to negative x cosine 2x to the both sides of the equation, we will get negative 8 a1 equals to 16, where a sub 1 is equal to negative 2. Equating the coefficient e negative x sine 2x, thus we will get a2 is equal to 0. So yp is equal to negative 2x cosine 2x e to negative x. Thus, the general solution, which is the summation of yc and yp, is c1 e to negative x plus c2 e to negative x cosine 2x plus c3 e to negative x sine 2x plus e to negative x 2x cosine 2x is the final answer of the equation.